Once an egg's boiled, you can't unboil it, right?
Well, it turns out you can unboil an egg. And this is using technology that we have developed.
But why would you want to unboil an egg?
Believe it or not, the fundamental science that went into unboiling the egg has led us into a number of applications, and this is all about clean, green technology, biodiesel, solar cell applications. This is the start of a lot of exciting possibilities with this technology.
The eureka moment for Colin's egg unboiling technology happened one night on a flight from Los Angeles to Sydney.
And it was during that flight that I was trying to solve a particular problem and started drawing the plans. I knew I was onto something really, really good.
The Vortex Fluidic Device, the VFD, solved the problem Professor Raston was working on, which was to find a new way to experiment in the field of microfluidics, the science of manipulating extremely small volumes of liquid.
So the device is a microfluidic device, but it's not your conventional microfluidic device.
In microfluidics, very small volumes of liquid are pushed through tiny channels, a process that produces some interesting chemical reactions. Colin's device manages to get similar reactions and even new reactions by rapidly spinning small amounts of liquid at very high speeds.
So in a way, it's a new paradigm in microfluidics.
This new paradigm led to some unusual discoveries.
We did not set out to unboil an egg. That is the consequence of the science. It's all about what we call protein folding.
Eggs contain proteins, long strands of amino acids which are tangled. When an egg is boiled, the weak bonds holding the protein strands together are broken, and the proteins are free to move around and make new bonds with other protein strands.
I'm going to add a bit of coloured solution so we can actually see when we put it in the vortex. The protein is like a bit of spaghetti, but it's arranged in a very specific way. If you can now readjust this coiled bit of spaghetti, put some energy in, so the liquid, it's forced against the walls of the tube, which is rapidly spinning, and it's then moving up, and it's this stress that you can use to start to refold protein. Then you've unboiled an egg.
There you have it. The egg is now unboiled.
The Chemistry Prize.
And his discovery didn't go unnoticed.
It is awarded to Callum Ormond and Colin Raston of Australia.
The Ig Nobel Prize is for research that makes you stop and laugh.
And I found a high-tech device that will allow us to distinguish the raw egg from the boiled egg.
But then makes you think. And the moment we got it, I mean, I was just shaking with excitement.
Thank you so much again for this high honor.
And it's an award that actually is growing with interest each year.
After the excitement of winning had passed, Colin asked his student researchers to investigate other possible discoveries that might be made. Using the same egg unboiling technology, they quickly discovered this process had a role in renewable energy.
So the first thing that we looked at was the production of biodiesel.
An alternative fuel, biodiesel can be made from simple renewable ingredients.
We are able to produce it from natural ingredients, so sunflower oil, vegetable oil, and it eliminates fossil fuel emission.
The problem with traditional biodiesel production is it requires high temperatures and some nasty chemicals, and typically gives low yields. But using the Vortex method, making biodiesel becomes much more efficient, requiring only low temperatures and fewer nasty chemicals.
and we can produce the biodiesel at a high yield, so 95% yield.
This is the biodiesel.
95%, that's amazing.
And biodiesel wasn't the only clean energy discovery Collins researchers made.
So I started researching carbon nanotubes. I thought it was a very exciting material. It has so many different properties. We can use it for so many different things.
Carbon nanotubes are long chains of carbon atoms arranged in a cylindrical shape. They're tiny, usually 1 to 3 nanometers thick. They're highly electrically conductive, 100 times stronger than steel, and very useful in solar panels. But to be used effectively, they first need to be untangled, just as egg proteins can be untangled.
When we receive the carbon nanotubes, they're really long. Basically, they're like spaghetti, so they're tangled spaghetti, and it is very difficult to separate them. So we thought, we need to find a method to cut them to shorter lengths without using chemicals, without using any surfactants, so additives, and how do we do that?
Using the intense rotation of the Vortex Fluidic Device, Kasturi was able to bend the carbon nanotubes, even though they're 100 times stronger than steel. But she still couldn't cut them.
And then the idea came of using just a laser. So what happens if we direct a laser to the tube? What will happen? And that kind of worked.
Using a high-powered laser, Kasturi was able to cut the nanotubes as they randomly passed in front of the beam, at the exact point where the intense spinning had bent them.
So if you have a few nanotubes that are at that spot, you're going to just basically take a scissors and chop, 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 chop. So that's what's happening at a nanoscale level. Yeah.
The combination of the laser and the Vortex Fluidic Device could cut the nanotubes into the required lengths. The value of Kasturi's work was immediately apparent to solar power researcher Professor Joe Shapter.
So in photovoltaics, one of the great advantages of nanotubes is that they conduct electricity exceptionally well. So these are the films that we've made now out of the short nanotubes.
But the big advantage of short carbon nanotubes is the possibility of building solar cells with electrodes so transparent they're practically invisible.
So, in this lab, we can take these short kind of nanotubes and we can make films that have greater than 90% transparency. So if we, for example, put that on a window or put it on any flat surface, the wall of your house or your car, you wouldn't actually even know it was there. We could make solar panels out of the windows. You can only do that with a really thin, flexible electrodes, and the short nanotubes give you that opportunity.
Unboiling eggs may have earned Professor Raston an Ig Nobel Prize.
So the Ig Nobel Prize, yes, it makes people laugh. It made us laugh, but we have the last laugh.
But with ever more clean energy applications coming out of his discovery, the Vortex Fluidic Device seems more noble than Ig Nobel.